Welcome to Cyber in Practice Episode 3. In this episode, I'll be demonstrating how hashing and integrity verifications work using SHA-256 hashing and Kali Linux. We'll look at how cybersecurity professionals use hashing to verify files, detect tampering, and validate data integrity. What is hashing? Hashing is a one-way mathematical process that converts data into a fixed-length digital fingerprint called a hash value. The important concept is that the same input always produces the same hash, but even the smallest change creates a completely different result. Because of this, hashing is widely used in cybersecurity for integrity verification and tamper detection. For this demonstration, I'll be using SHA-256, which is part of the SHA-2 cryptographic family. SHA-256 generates a secure 256-bit hash value and commonly used for file integrity verification, malware analysis, password protection, digital forensics, and software validation. Integrity verification ensures that data remains accurate, trusted, and unmodified. Cybersecurity analysts use hashing to detect unauthorized changes, validate trusted files, and identify tampering and corruption. If a file changes in any way, the generated hash value also changes. In this demonstration, I will access an existing file inside my hashing demo directory, generate an original SHA-256 hash, save the hash value, modify the file contents, generate a new SHA-256 hash, and compare both hashes to demonstrate integrity verification. The tools I'll use is Oracle VM VirtualBox, Kali Linux, Linux Terminal, Nano Text Editor, and SHA-256 hashing. Now let's get into the live demonstration. I already created my hashing demo directory ahead of time for this demonstration. I'll now move in the project directory where the files are stored. Next, I'll display the contents of the file that will be used for the hashing demonstration. For the purpose of this demonstration, I just typed 1 through 9. I will now generate the original SHA-256 hash for this file. The hash acts as a unique digital fingerprint for the file contents. As long as the file remains unchanged, the same SHA-256 hash will always be generated. I will save this original hash value into a file called original hash. Next, I'll open the file using the Nano Text Editor and make a small modification to simulate file tampering and unauthorized changes. Now I'll generate a new SHA-256 hash for the modified file. Notice that the new hash value is completely different from the original hash value. Now I'm going to save the new hash value in a separate file called modified hash so we can compare it with the original hash side by side. Now let's compare the original hash and the modified hash to see if we notice any differences. You see how the modified file creates a completely different hash? This difference is what allows cybersecurity professionals to quickly identify when data has been changed or tampered with. So to wrap everything up, we saw how SHA-256 hashing creates a unique fingerprint for a file. And we also saw how changing the content of a file results in a completely different hash value. This is why hashing is such an important part of cybersecurity. It allows analysts to verify integrity, detect tampering, validate software, and support forensic investigation. Hashing is widely used across cybersecurity for things like malware analysis, password security, and system monitoring.
Thank you for watching Cyber in Practice. If you enjoyed this demonstration, stay tuned for future Cyber in Practice episodes.